In this lesson, we will explore the concept of training the model through the data. Let's start with an example. You have a coffee machine that doesn't know how to make coffee. In a non-machine learning setting, we would need to incorporate the instructions in the machine's electronics, or at least that's how all coffee machines I have seen work. For instance, the engineers may set the machine's electronics to: first, grind 20 grams of coffee beans. Second, heat the water to 200 degrees Fahrenheit. Third, pour 100 milliliters through the ground coffee into the cup. Now, in a machine learning setting, we won't explicitly provide instructions to the machine. Instead, we just need to state our goals. In the coffee machine case, that would be produce a cup of coffee. Then we would let the machine work out the problem on its own. The machine learning process is a kind of trial and error training. The machine would try various combinations of grinding, heating, and pouring. Most would not make sense. The machine would try heating the water and pouring it before grinding the coffee, resulting in a cup of hot water. Or it may grind the coffee and pour the water without heating the water. Anyhow, after thousands of trials and errors, the algorithm would train itself to reach the set goal every time. It can make a cup of coffee. It is possible that it will learn to make the best coffee you have ever tried, much better than the one obtained by following a set of instructions. That's because it would have gone through so many more recipes than a human would ever be able to. A reasonable optimization algorithm would not try all combinations, as there are usually inexhaustibly many other options. In the coffee example, if the coffee machine learns that grinding the coffee has to go before pouring the water, it would not waste time attempting it in the wrong order. We'll talk more about optimization algorithms soon, don't worry. This example shows us why machine learning is so powerful. It allows systems to learn on their own situations, where humans cannot define a rigid set of rules for the computer to follow. Even if we can define a set of rules, an algorithm can probably provide a better one. Before wrapping up, let's explore another interesting instance: self-driving cars. Contrary to what many people think, self-driving cars don't follow rules such as avoid curbs. Essentially, they train on thousands of hours of footage of real people driving and learn how to mimic them efficiently. It is not the set of rules they know, but the final goal. The final goal fundamentally is to drive safe and efficiently. Avoid curbs, don't bump into other cars, don't go over the speed limit, stop at red lights, and so on. Okay, now that we know training data is at the core of the process, we can differentiate between different types of machine learning. Stay tuned, and thanks for watching.